Hi folks, welcome to my Retro Journal. Today I'm going to do a little bit of coding on my ZX emulator. Last time I actually updated it a bit to add two-dimensional arrays, and what I want to do today is actually so one of the problems I find is if you take a look at so if I look at the one before I modded it, you can see that its size is 48.5K, and now I'm up to 49K 300 bytes, and it doesn't seem like a lot. So this is the old one, and it doesn't seem like a lot, but you know, when you're trying to run it in 128K QL, which 86K is free, you don't want the executable to actually get too big. So this is I'll show you how big it is. So again, just some background. This is the ZX emulator, which is a ROM emulator. So this one is 48,668. So this does not have the two-dimensional arrays. And having added two-dimensional arrays, you can see that the next one, you can see the size. And a ROM emulator is basically where you try to recreate the ROM of an old 8-bit computer. Different from a machine emulator, where you're trying to just recreate both the CPU and the entire sort of architecture. Now, some of you might look at this and say, isn't just a ROM emulator just a basic interpreter? And it is. In fact, that's how it started. I used my prototype from back in the 90s, but that's about 20% of the engineering. The real task is trying to get everything to work. Yeah, so you see this is 49,300, so it's gotten bigger, and I want to shrink this down again, so that's what I'm going to do today. But yeah, so most of the work on a ROM emulator is trying to get it to work exactly like the other ROM. So but I'm not reverse engineering the ROM, because this is not running on an actual machine. This is, you know, a ROM emulator is actually emulated on a QL, emulating the behavior of the ROM. But it turns out that, let me get to, so that's 7, 6, 5, 4, 3. It turns out that a ROM emulator and a machine emulator actually aren't that much different. 20% of the effort probably goes into writing the interpreter, and then the other 80 is just to make it work with all the nuances. I would say the same goes with the machine emulator, and in fact, emulating a CPU is actually not that much different from emulating a language. They're both just a long switch statement of instructions. The difference is with a ROM emulator, the instructions are higher level, like print, or let me go in here, let me start this, like print or clear or whatnot, which is a string of ASCII characters, which is a string of binary characters, while a machine emulator is also a string of binary characters, binary values, but they're just shorter because you're dealing with actual machine instructions. And then the more difficult part of let me do Command C. The more difficult part is getting all the rest of the architecture of the actual hardware to work, graphics, memory, etc., to work with the CPU chip. One thing I did, by the way, is I set I locked the focus and contrast so that this wouldn't keep changing, and I'm hoping that this is a pretty good I might be able to brighten this just a tad. There we go. That's probably, yeah, that's probably as good as you're going to get it. So but if you take a look at it, you'll see that this is the basic interpreter, and it's going to have a long set of switch statements in the parse command right here. Actually, it's basic commands, and that's what you have if string equals, etc. So one thing that I noticed is that in the I have another command which is called GetKey, and that's the one that I actually want to replace. Where is it? GetKey. I can just search for it. F3 find GetKey. And so the way this currently works is, yeah, so you can see GetKey step, for instance, is a perfect example, or GetKey 2. And so the way I want to get this to work is, so instead of doing So notice that the string equals, it's no different from a string comp. In fact, I'm going to get rid of string equal. It's a function that I wrote to be efficient, but it turns out the strcmp in digital C is just as efficient. The difference is that I have, so string equal returns a 1 if it's true. strcmp returns a 0 if it's true. So I just have to do the not of that. But what I want to do is I want to replace all the string equals with GetKeys, because the way string equals works is if I go to the top of the file and then find get command, you'll see that what I do is I grab a command from the string buffer and put it in a variable called cmd, and then I feed that into basic commands and do a string equal. Whereas with GetKey, I actually stay in the string buffer and just compare it right then and there. So they're kind of doing one and the same, and so I'm kind of wasting some space doing it two different ways. So I'm going to get rid of get command. Before I do that, I just wanted to show you that I actually fixed the bug, which was in the let command. So if I do let, so find let. This has been fixed, and the place I had a bug in this is right here. I can point to it with a pen. What I was doing is I was setting aside some memory, copying the old thing into the new, and then creating my new size memory, which was L plus G plus 1, and then setting that aside. And I was copying everything, but at the end, what I was doing is I was copying from, not from the end from L, but just from one less than. So I was what I was missing. So a C string needs to be null terminated, and I was basically copying the last element. This goes backwards. So I was copying from the last element to the insert, but I wasn't copying the null character. And so when I was doing a string length, this was causing an issue. And so what I've done here is, where am I? Just to be a bit more efficient, since here I don't use the length anymore. Instead of saying, before I was saying memarg L plus G plus 1, I just set it here one time, L equals L plus G plus 1, do the memarg, and then at the very end here, so I don't have to set anything, just to be a little bit efficient, I just use it. I just basically modify L directly, and I go from the last element, which is what L, so the minus minus happens after I access it. So I basically set the last element first, which happens to be the null pointer, so that the string is null terminated. And that will get rid of that weird error if you watch my previous video. It also reduced the size of this a little bit, but by about 10 bytes, because I wasn't doing an I equals, here I was doing anything in I equals L. So now I just have set the L up here already, and so I don't need to set it again. So just a little bit of efficiency. But yeah, today what I want to do is get rid of all the get commands, because I'm not going to use them anymore. So I don't need this string right here anymore. And so I can just actually get rid of that. Here we go. I don't need to pass it in anymore into parse command. So I can get rid of this. And all these is going to save me some. And what I'm basically end up doing is I'm going to get rid of a couple of extra functions and reduce the size of that. So again, here I'm passing in the command, which was a buffer of, I think, 40 characters or 80, I forget. So I don't need this. Yeah, or this. Let's make sure that the original one didn't have it. I think it was defined just at the top. Yeah, the main one. Okay, perfect. So going back down, I'm going to get rid of all of the, I'm going to do search and replace for most of this, but I just want to get rid of all of the instances of command since I'm no longer going to use it. So here we go. Okay. And then in basic commands, again, I don't need this anymore. And I'm going to get rid of that, as well as that extra line right here. All right. So, and then this is the last function in this cmd.c file. And what I basically want to do next is I just want to, I believe if I do an F1, the call that I want to do is a search, is it squery? Let me see what, right, exchange query. So EQ is the one I want to do. So I can go out. So what I want to do is F3 exchange query, and I want to exchange strEQL with GetKey. And then here I can just go yes, search again, yes, search again, yes, search again. And this just makes sure that I don't have string equals in any other place besides, see here I don't want to do it because it's within, so this is actually going to be no. That's why I don't just do a global one. Yes. Yes for the if, for the input, for the let, for the list, load, new, next, pause, plot, unplot, print, rand, ram, return, run, save, scroll, stop, quit, and then you have these two. And so this one basically we no longer have, we're no longer checking that. So this is actually going to go, oops, it's going to be an else, and we're just going to do that to line up. So if there's no, if no more command, I think is what I want to write here. Then if it's not GetKey, we return no command. Otherwise we're, yeah, because we don't support those. So I'm going to go, so this is the end of the function. And so I'm going to go back to the top. And I'm going to F3, find strEQL. And I have one right here. And as I said, I can get rid of this and just do not as strcmp. I don't think I have another one. Yeah, so that's it. So actually, I think I'm done. Oh no, I'm not quite done. So I want to F3 top. And I want to go F3 find basic and do it again. Yeah. So what I want to do now is I want to, so this is still the wrong command. I want to say get clear. So I'm going to do a search and replace for copy cmd close paren, and this time I can just do an exchange. F3 instead of exchange query, I can say comma cmd close with close equals no error, and just do a change. I think this is, oh, just keep changing globally for all these, and this is basically going to do, so yep, it's changing them all. So basically just saying if GetKey load equals no error, and so the idea here is I want to both reduce the size of my code but also not slow it down. I think I can do that with these functions, and I think that's it. Yeah, no more search. So I think I can, there you go. So now this says if if GetKey equals quit, and then if, and I don't have to say not GetKey here actually, so I can just say if GetKey does not equal no error, and does not equal no error. So if it's not fast and not slow, then return no command is basically what I want to do here. And I think here I can just return that here. Yep. So I think that's it. I think I'm done with my. So if it's fast, if it's not fast, then it's. If it's not fast and it's not slow, then return no command. Otherwise, we ignore fast and slow since we're not implementing it. All right, let's save that. And so you can see the other ones now are GetKey quit equals no error. So this is a nice if that kind of follows all the other GetKeys I've already implemented. And now all I have to do is change it in one more place. So read in. And this is in MVV3 aux C, and that reads in the auxiliary stuff, which has all of those functions. And for that, you can see that it's reading it in now. It's the get command that I actually want to change. So yeah, I changed all of the. I got rid of all the get commands, and so now it's the first one right up here. So this is the one I want to get rid of. Because what it was doing before is it was literally, yeah, so I'm just going to be the lazy way. I'm just going to delete it this way. So it's basically just reading it into a buffer. And what I have is the get key right below it. And so what I'm going to do is, yeah, I'm just going to wipe that clean. And get rid of the extra, oops. The extra line. Okay, so this is going to get a keyword, but then if you notice right below it, I also have get symbol, which is really more like a get token. But so the way I want to change this is I'm actually going to, so my get symbol kind of works the way I want, and it basically skips all the spaces, sets my original pointer, which is a global, to the current pointer called SP. Oops. I'm just doing a little bit of code cleaning here. I like to have spaces in there when I can. So this is going to basically go through my symbol string until the till the end of it. And if I return. Yeah, so one thing, by the way, I've realized in terms of speeding things up is Digital C does a really bad job with regard to arrays. And so when you do arrays, it's best to do minimal amount. So the I++ actually happens. So this will take up slightly more space, but it's actually going to be a bit more efficient in terms of speed. So that's just, you know, when you use a compiler enough, you kind of realize how it works. And I've learned that this, so I was doing the increments inside of the, so I was doing an SP++, which did the indexing, then incremented it, and I did the I++, did the indexing, then incremented it. Whereas here, this basically will do it if it continues in the loop. So it's actually going to do that one less anyway, so it's a bit more efficient time-wise, but also I think space-wise. And not having these pluses inside of the subscripts actually helps it. It's weird that way. Then the other one is, so on GetKey, you can see that I'm kind of doing the same thing. And what I want to do here instead is, I'm going to get rid of all of this stuff. And so I don't actually need to be repeating the wheel here. And so so instead what I'm going to do is, yeah, so instead of doing that, I'm just literally going to get rid of all this stuff. And, oops, yeah, I don't need to be doing any of this stuff. All right, and so all I have to do here is say, if getSim key equals no error, then what I can do is actually execute this if as follows. And so what I want to do here is I'm going to if string. So now, because the difference between key and command is that a key would only ever appear after something else, like even after a new line, a line number, but a command could appear as if you're typing stop or new or whatever on the command line. So it adds one additional element, which is if I want to say if not OP, in other words, if it's not 0 and, because if it's 0 then I'm at top and I don't want to check. What these check is delimiters, like spaces and commas and whatnot around a keyword. And of course, if I'm at the beginning of the line, I don't have that, and so I don't want to check that. By the way, notice I should really be doing if string delim str_spp and not op and string delim string op. But I've learned does not equal null. I've learned that doing ANSI, in other words, if I got rid of this and just did a and then I could get rid of this one here as well and just have an AND. Right, so just string these together. The problem is it's just not very efficient doing an AND. I've learned that more efficient is just stringing together the ifs. In terms of it generates less code. I don't know why, but it's just not very efficient. So if I string them together like this, it ends up being the same thing. 3 ifs together is the same as an AND of if and if equality and equality and equality. So this is actually just a bit more efficient. And so if I do it this way, what I can do then is return. So I want to do this. Right. So this is going to go inside of. So if this is all good, then 1, 2, 3 is going to go inside here. And then it returns no error. Otherwise, yeah, I don't actually need to. So if key, yeah, if GetKey equals no error, then here I want to do is set my SP back to my original pointer, and then quit. So I don't need to have this funky thing anymore. Yeah, I think that's that. Let me make sure. So I think that reads best. So if my get key is no error, so I got a proper key, then if it has a proper delimiter, it returns no error. Otherwise, I reset my string pointer to my original pointer. If getSim does return an error, then getSim actually did the SP equals OP. If you can see, as it's returning an error down here, it does that right here. SP equals OP. So, but whenever something bad gets returned, it gets reset anyway. So this will return a bad car if it's a bad keyword. Otherwise, so I think this will do it. So the only other thing I want to do is I want to find F3, find str equal. It's in here, I think. Yep. So I'm using it right here, and I want to get rid of that. And do a not strcmp. Do another find. Here's another one. So F2 lets me repeat the last command. strcmp. So I find that this is, and this is the actual string. So I was doing some really efficient string equality by using pointer arithmetic. But it turns out that strcmp does it the same way. So I'm going to get rid of this function because I don't need it. And there is actually, I can block delete if I wanted to, but this is just fast enough. Let me make sure that, yeah. So So that's, oops, one more extra one. So this is fast enough. So I got rid of the extra string equals. I think that's enough, so I should be able to just save it. And what I'm going to do next is compile it, and I'm not going to have you sit through the compile. I'm going to come back to, I can quit, and this should actually take me back to ICE. Yeah, which is just a little brighter than I want, so I should probably reduce this down a little bit. Yeah, it's better. And so I'm going to compile it, and then I'm going to check the new size, and then I'll come back. So let me do that. Okay, it finished linking, and so now what I want to do is check both the size and the speed. I did have two bugs in my implementation. Command.c, I actually forgot to take out the get command function call. And then in my GetKey function, I forgot, I had an and, I needed a logical or. So let me go, I'm actually going to reboot the computer because I don't think it'll otherwise work anyway. So let me do that. I'm going to go into ICE. In ICE, what I want to do is check the size first. And that should be the 8th microdrive. Originally, before modeling it, it was 48,668 bytes. After it was, adding the 2D arrays, it was 49,300. I'm going to see how much it is with my new modifications on there. And then I want to add a speed. So having added 2D arrays, I think it's going to slow things down because I'm doing more with, oh, so it's 48,600. So, it's actually 668 bytes smaller. That's not bad at all. So what I want to do now is actually run the speed test. Okay, so load the banner program. That's my usual test case, and it's the fastest. Well, the current mark is about 1 minute and 28 seconds, and so that's what I want to check. I do have a stopwatch that I'm going to use to test this with, and so let's see how this new modification compares to that 1 minute and 28 second mark. And so I just need to load it in and hit the old go. So and then time it. See if I can get it under 1 minute and 30 seconds. But it is going to slow down because I did change. The banner program does test the string accesses, and that's the thing that so I don't think making the program smaller is going to slow it down, but I think the 2D array stuff is going to change that. So let me, all right, here we go. You can hear the beep of my watch. And I'm looking for, yeah, about 1.5 minutes would be good. But the original one is 1 minute and 28 seconds. That's sort of where or just under that. 128, 127 is kind of where is the standard. And I want to see how fast how close I can get to this. I don't think it's going to match up to it. It's got to be at about 44 seconds at the halfway mark. And I think we're not. We just reached 44 seconds now, so it's just slightly slower. We're at 46 seconds. So if we can hit 132, that wouldn't be horrible. It'd be about 4 or 5 seconds slower. Yeah, and that's just what happens when you, this isn't a slowdown across the board, but it is just something that happens when you're adding features. And again, I did reduce the size of the code, so that's nice. So I have more room to add other features. But yeah, doing string manipulation, I mean, especially the get range function that I modified, we'll have to see if I can make any optimizations in that. But I'm about to hit the final mark, so let's see what we end up with. About 4 more seconds, and stop. Yeah, so it's 1 minute 33 seconds. So it's about a 5 second loss here, and so I'll have to figure out a way to gain some of that back. But that's where we are, and I've got a new feature, reduced the size of the code, but slowed it down slightly. So that's the current version of ZX Emulator. Thanks for joining me today on sort of this optimization part of writing an emulator. You win some lower size, and you lose some slower speed. But I'm sure I'll find something in the future to give me a few seconds back as well. All right. So thanks for joining me, and I'll see you next time.